In this video, I want to find the partial fraction decomposition for the following fraction. The first thing to notice is that we have two pieces to the denominator. If I set each one of them equal to 0, I get a nice real solution. Okay. So the way we're going to do this is we're going to have four different fractions. Two of the fractions will have the denominator involving r squared, and the other one will be the r+2 squared. But with r squared, you want to go in increments. So you first start off with the first power, and then go to the second. Same thing with r+2 squared. If I set the denominator is equal to 0, I'm going to get a nice real number. So that means I could just put a, b, c, and d at the top. If, let's say, one of the denominators was r squared plus 1, then I would need ar plus b at the top, because r squared plus 1 does not equal 0 for any real number. Okay, so these two, so the top fraction is equivalent to this. Our goal is to solve for a, b, c, and d. So the first step to this problem is to multiply both sides by this denominator. And when I do that, this gets canceled out. So I'm left with 4 times r plus 1. And now on the right side, the r gets canceled, so I have r times r plus 2 quantity squared. The r squareds get canceled, so we have b times r plus 2 quantity squared. The next one, the r plus 2 gets canceled, so we have c r squared times r plus 2. And the last one, the r plus 2 squared gets canceled, so we have dr squared left. Okay. So we've simplified this a decent amount, but we still need some work to do. Okay, so the next step, I'm going to find different values of r. Okay, so there's some good candidates. What I'm looking for is whatever's inside the parentheses, or really any of the r factors, to be 0. Notice I have r squared, so why don't I pick r equals 0? That's going to knock those out. Okay, so I have, on the left, 4 times 0 plus 1 is 4. On the right, r0, so that gets canceled. And then plug in r equals 0, so I get 2 squared times b. The cr squared gets canceled, and so does the dr squared. So then b here is 1. Now let's look at another candidate. Notice 3 of those terms have factors of r plus t. So why don't I choose r equals -2? Pulling it on the left-hand side, 4 times -2 plus 1 will give me -4. And on the right, I can just look at dr squared, because the other 3 terms will get canceled. So I end up getting, let's see, -2 squared d, which is 4d, and I get d is -1. So now I have 2 out of the 4, so I need to solve for a and c. And really there's not an obvious choice for us, but I don't want to make this too complicated. So why don't I choose r equals 1? That's very nice. On the left, it's 4 times 1 plus 1 is 8. And on the right, let's see, I have 1a times 3 squared, so that's 9a, plus b is 1 from over here. And then it's 1 times 1 plus 2 squared, that's 9, plus r squared is 1 times 3, so that's 3c, plus dr squared, well, r squared is 1 times d, that's -1. Okay, so 9 minus 1 is 8, and that's going to get canceled out with this 8. So I have 0 equals 9a plus 3c. And I'm going to leave it as is, and then we're going to look at r equals -1. Let's see, on the left, actually -1 is a good choice because on the left it becomes 0. And then we have -a times, let's see, -1 plus 2 is -1 squared is +1. So that's -a. b, let's see, it's -1 plus 2 squared is 1 plus b. b is also 1. So that's 1. r squared is 1. r plus 2 is also 1. So that's just going to give me c. And then d is -1. r squared is 1. So that's -1. Notice the 1 and -1 are going to cancel. So I have 0 equals -a plus c. So I have now a system of two equations and two unknowns. 9a plus 3c is 0. -a plus c is also 0. Multiple ways to solve this. Let's multiply the bottom by 9. So in other words, we'll put in a 9 here. And we get that 12c is 0. And then c is also 0. So if c is 0, plug in c equals 0 here. We get a is also 0. Okay, so now we have everything we need. A is 0, c is 0, b is 1, and d is -1. So I can go back here. A we said is 0, b is 1, c is also 0, and d is -1. So the ones with a 0 numerator get canceled, and what remains is the b and the d fractions. So we have 1 over r squared minus 1 over r plus 2 quantity squared. And this is my final answer.